Alright, what's up guys? In this video, we're going to pick up with some differential equations, and we're going to solve a Bernoulli's ordinary differential equation. So you're given dy over dx plus 1 over 4 multiplied by y is equal to e to the x multiplied by y raised to the fifth. So Bernoulli's equation is just a linear equation, and it takes a following form. So Bernoulli's equation takes the form y prime plus p of xy is equal to q of x multiplied by y raised to the n. So the first thing we need to do is identify what p of x is. Let's identify that first. So p of x here is 1 over 4. We need to identify what q of x is. Q of x here is the exponential e to the x. And then our n here is 5. And we need to identify what y raised to the n is, and y raised to the n is y raised to the fifth power if we look at what we have. So remember, the way you solve these is you do the following substitutions. V is equal to y raised to the 1 minus n. If you differentiate v, you could basically write it two ways. V prime would just be equal to 1 minus n multiplied by y raised to the negative n multiplied by y prime, or you can write v prime as 1 minus n multiplied by y prime all divided by y raised to the positive n. So same thing, it's just a different way of writing it. And then you plug that into the differential equation to give you 1 over 1 minus n v prime plus p of x v is equal to q of x. Alright, so the first thing we need to do for Bernoulli's equations is we need to divide by whatever y raised to the n is. So y raised to the n here in this case is y raised to the fifth. So let's start by dividing that equation by that. Remember, dy over dx, that's the same thing as y prime. So keep that in mind. So y prime divided by y raised to the fifth is equal to 1 over 4 multiplied by y divided by y raised to the fifth. And then we'll have e to the x multiplied by y raised to the fifth. We'll divide that by y raised to the fifth as well. And then we'll just do some simplification. So we'll have y prime all over y raised to the fifth plus 1 over 4 multiplied by y raised to the positive 4. And then if we divide this side by y raised to the fifth, obviously the y raised to the fifths just cancel out, leaving us with just the exponential e to the x. Then we do the substitution. V is equal to y raised to the 1 minus n. So that means that v in our case will be equal to y raised to the negative 4 if we do the substitution. V is equal to 1 minus n, because y to the fifth was our y raised to the n. So 1 minus 5 is negative 4. So that's where that comes from. And then if we differentiate v, we'll simply get negative 4 y prime all divided by y raised to the positive 5, because I like using positive exponents. I don't know about you. Okay, so basically what we have to do is plug this stuff into the equation. So we'll get negative 1 over 4 v prime plus 1 over 4 multiplied by v is equal to the exponential e to the x. And basically what you do for these types of equations is you solve them as first order linear equations. So if you remember from the first order linear equations, when you solve it using integrating factor, we can basically do the same thing here, but we need to get in the correct form right now. So let's multiply both sides by negative 4. That's going to make this v prime over here positive, because we need in the correct form right now. So if we multiply both sides of this by negative 4, we'll simply get positive v prime minus v is equal to negative 4 times e to the x. That's if we multiply everything by negative 4. Okay, so the next thing that we need to do is we need to identify the integrating factor, which I'll just denote if in this case. And remember, that's just e raised to the integral of p of x dx, or in some differential equations, depending on the variable that's given, it may be e raised to the integral of p of t dt. In this particular case, we're dealing with x here, so it's going to be e raised to the p of x dx. But it can be p of t dt, depending on the variables being used in the equation. As I get another sheet, we'll identify what our integrating factor is. And again, I'm just denoting integrating factor IF just for short, instead of having to write the whole name out. And so if we do e raised to the integral of p of x dx, then that means that our integrating factor will be e raised to the negative x, because our p of x, if you look at what we have, would just be -1. We would integrate that respect to x, which is integrating a constant respect to x, which gives us -x. So our integrating factor is e to the -x. The next thing we do is multiply both sides of the equation by e raised to the -x, so that integrating factor. Apply the product rule on the left-hand side and integrate the right-hand side. I've done videos on solving first-order linear equations before with using integrating factors, so check out my videos on that. Because if you don't know how to do that, you'll probably get lost with Bernoulli's equations. So make sure you know how to do that prior to starting. I did some videos on that, by the way. Okay, so then we'll have a minus v multiplied by e raised to the -x, and then we got to do the same thing over here. So it'd be -4e to the x multiplied by e raised to the -x. And so if we do some simplifying, if we apply the product rule over on this left-hand side after we've done a little bit of simplification, we'll get e raised to the -x multiplied by v. And then over here, we're just going to be left with, looks like we're going to be left with -4. And we're going to have to integrate that side with respect to x. Okay. All right, so hopefully you're with me on that so far. So if we integrate -4 with respect to x, we're integrating a constant with respect to x. So that's -4x, technically plus c, to be technical with it. Okay, so what we'll get is e raised to the -x multiplied by v is equal to -4x plus c. We need to isolate the v over here, so we'll divide both sides by e raised to the -x. So if we do that, well, then we'll get v is equal to -4e raised to the x multiplied by x, and then this would be plus. I'm gonna bring the, if we divide by e, I'm gonna bring the e to the x up front. So it'll be e to the x multiplied by c. So we divided both sides by e to the -x. All I did was just move the e to the x up top to make it a positive e to the x, because again, I like positives, not negatives. So now if you go back to the original substitution that we did at the beginning, remember v, if you remember what our substitution was y raised to the -4th. So you just have to plug that back in for v, basically. And you see what you get from there. Okay, again though, if we substitute v is equal to y to the -4 back in there, as I said before, I don't like negative exponents. Maybe you do, I don't. So you can just write v as 1 over y raised to the +4, which will probably work out a lot better. So then we'll have 1 over y raised to the +4 is equal to -4 e to the x multiplied by x plus e to the x multiplied by c. Multiply both sides by y raised to the 4th. I'm going to switch sides a little bit here, and this will become -4e to the x multiplied by x multiplied by y raised to the 4th. And then this would be plus e to the x multiplied by y raised to the 4th multiplied by c. And that's going to be equal to 1. That's what will be left on this side if I multiply both sides of this by y raised to the 4th. Because we want to get rid of the y raised to the 4th. That's the purpose of it. Now, obviously, what we need to do is isolate the y raised to the 4th, because what we're trying to do is solve for y. So we could end up factoring out, you could just factor out a y raised to the 4th, or you could factor out a e to the x times y raised to the 4th. It's entirely up to you on this left-hand side. And so if you did that, well, then that must mean that we'll end up with -4x. Looks like we'll have plus c in there. And you can always check to see whether or not you factor something correctly by distributing it back in. And then clearly we can divide both sides by e to the x times negative 4x plus c to isolate the y to the fourth. So that'll give us y to the fourth power is going to be equal to 1 all divided by the exponential e to the x multiplied by negative 4x plus c. Now we need to solve for y, so you could take the fourth root of both sides. But remember that taking the fourth root of all of this is the same thing as raising it to the positive 1 over 4. So when we write our final answer, we can just write it that way instead of writing it as the fourth root. So our final answer when we solve this Bernoulli's equation is y is equal to 1 over e to the x multiplied by negative 4x plus c, all raised to the positive 1 over 4, because taking the fourth root of all of that is the same thing as raising all of that stuff to the positive 1 over 4. So that would be your solution. So this does take some practice, but overall, I think it's a pretty straightforward process. All right, so that's Bernoulli's equation. So if you got any questions about how I arrived at my answer, feel free to ask. I have no problem explaining it, but that's going to be your answer, and I will see y'all next time.